Thank you, Rava. Thank you, everybody. And let me just thank all the organizers for inviting us to this nice workshop. Even during the pandemic, we are able to do this. That's really great. We wish we can go back to our Stony Brook game theory conference and mingle with people and have a lot of fun, but we couldn't do that for last couple of years, and really hope to do that next year possibly, right? That's that's the big hope. Okay, so so this paper is again looking at licensing contracts, but I'm going to change the framework. This framework is a spatial competition. So so basically conventional frameworks like Cournot and Bertrand, we have seen a lot of that. So I'm going to move to a different framework to ask very similar questions on optimal licensing contract. Specifically, I'll refer to Hoteling's framework, and I'll tell why Hoteling's framework is a relevant one in this to address this particular question. This is a joint work with Arijit. Arijit is around. Arijit Mukherjee and Swapnendu Banerjee. Swapnendu is based in Kolkata, India. Since Arijit is around, as they say, that all the difficult questions for this will go to Arijit. So Arijit will answer the difficult ones, and I'll take the easy ones. Okay, all right. So, so that's with that. Okay, so let me just get started. So we already know that since Yeri is sitting right here, one of the pioneering work on patent licensing is originated from Yer's work with a lot of co-authors, in particular Chapman and Tauman in 1986, and there's a series of papers and literature that have originated from that. And the same goes with the other two co-authors, Katch and Sapiro, 1986. And I really wanted to ask here at some point that when you are working at patent licensing in 80s, of course, there's no study before that, right? I think it must be a completely different kind of world you have started to work on. We'll talk about that later. But interestingly, that literally gave us huge sort of things to look at on optimal patent licensing in various frameworks and in various situations. The conventional framework that you already know is the usual Cournot and Bertrand competition, and a lot of papers, a lot of questions and are answered in those framework. People looked at various aspects of licensing, starting from all kinds of licensing mechanisms, and then looked into the welfare aspects and whatnot. All kinds of questions are addressed. Two main directions that basically branched out is one is dealing with outsider patentee, and the other one is insider patentee. And each branch has, again, significant amount of contributions on those, conventional framework of Bertrand Cournot competition. So these are like the origin and early studies. And more recently, since Devopri is also here, again, Shen and Tauman, 2007 and 2018, moved to write a more general licensing contracts. General in a sense that instead of considering a linear Cournot framework, I think what Yer and Devopri has considered more of a general demand function and general cost function, and then looked into general licensing contracts, and special cases are linear demand with Cournot and Bertrand cases. So basically literature has also moved to another notch higher, addressing the general licensing contracts in a more general framework, and probably Pradeep was referring to that at some point, and some of the questions can be now answered more holistically when you look into these general licensing contracts. So those are the studies that has been done in the framework of demand and cost in a general framework as well as a linear framework. Now, mainly the objective was to find optimal licensing contract in various situations. So basically, you're trying to find a better contract. So we start with a very simple like fixed fee or royalty, and then you look into a two-part tariff, a combination of fixed fee and royalty. And then we, see what is, what we can add if we add, auctions to that. And so basically the big question that is always, we're striving to answer is what is optimal licensing contract, in a more general framework. So that was the progress, of research for the last 20, 30 years on patent licensing. Now, while looking into this literature back in 2004, me and my co-author, Sina, we realized that most of the patent licensing literature, that was addressed in a conventional framework of Purno and Batra, one framework is particularly missing. Now that framework is, we all know that in industrial organization, the hoteling's framework of spatial competition plays a major role. And until that point, early 2000, there was no paper on licensing in that particular framework. And let me tell you why that framework is relevant. One of the things that we capture in hoteling's linear, city model is inelastic demand. In other words, the consumers, they buy exactly one unit of that good. And what could be a good example? The good example, think of, the smartphone that is next to you. Usually we go for one smartphone. You just need one smartphone. And then of course we have our preference. Somebody prefers Apple, smartphone. Somebody prefers the Android variety. So basically it's like two brands, but usually we use one particular, unit of that good, okay? And hoteling's framework particularly fits into that, that describing that kind of situation very well. And of course, there are many other examples like, think of a brand. We prefer one brand, right? Even like fast food and beverage industry, somebody would prefer to go to McDonald's, somebody would prefer to go to, I don't know, Subway. So it's basically, it's like you're consuming one unit, but you are choosing your preferred unit. And that's basically the product differentiation model that is captured through hoteling's framework. So I thought that was a very kind of a robust kind of a framework. We can capture lots of, our economic, situations and demand that we are looking here. And where we can really study, and see whether the licensing contracts, if we bring the patent licensing, analysis, whether the licensing contracts are different from the one that we got in the conventional frameworks of Purno and Batra. So that was, one of our original sort of motive to why we want to, look into this particular framework of spatial competition. So that was the starting point. So in that sense, we can say, we have got some of the pioneering work in 2004. And actually, after that paper was published, I saw there's a lot of paper now coming using that framework of, spatial competition to address the question on patent licensing. So
just as an anecdote, let me tell you that Kenneth Arrow used to be, he did the PhD under hoteling.
Oh, yes.
And he told me that actually the dissertation of hoteling had a serious flaw. I don't know if he corrected it later, I'm pretty sure yes, but the dissertation itself is wrong.
Of hoteling.
That's what Arrow told me. Okay.
Okay.
It's because papers came out and corrected paper.
Can I add something? Hotelling's mistake was corrected by people at CORE in the paper by Dapramont, Gabsevich, and T.
Okay.
Yes, absolutely.
Corrected by Claude Dapramont and Jean Gabsevich.
That's right.
Okay.
Exactly.
Now I recall.
And
yes,
later, after they found that, after they published their paper in Econometrica, they met Arrow, who told them the same thing he told you.
That what? Say it again?
He had known about the mistake, but didn't want to write a note correcting it because it was
By the way, when did they do it? Because Arrow told me in 1982.
No, they published it in 1979. So just at the time you were at CORE.
Oh, I see. 79.
At that time you were doing cooperative games, so maybe you didn't pay attention.
Sorry for the interruption.
No, I think that's a very relevant discussion because, exactly the hoteling's problem and existence problem with Nash equilibrium. And that's basically why, the Gabsevich-Dapramont paper kind of fixed it. So yes, I mean, this was a big work. And just as a side remark, I want to say Gapsovich was my PhD thesis supervisor, and Rava knows about it.
I was going to add that, Sougata, but I left it to you to say.
Okay.
All right.
Nice.
Yeah. We'll come to this, discussion maybe later. Okay. So let me just move on. So basically, staying into the spatial framework of like hotelings, we did follow up with few other studies, in the later years. We looked into, the case for outsider patentee, the case for insider patentee. In that framework, when there are like two firms, sitting at the edge of the linear city, we looked into optimal licensing contracts. So just to give you one quick result here, in 2014, when you looked into the insider patentee, so there are like two firms, one is the innovator, other is the licensee. You will always find a two-part tariff is really the optimal licensing contract. So we actually initially started with the like fixed fee and royalty, and then kind of improved upon, to find a better licensing contract for the innovator. And the result was this was always the optimal one. We go for a two-part tariff, fixed fee and royalty, and both the components and are none of the components are zero. So there's a non-trivial value attached to each of these components, and that comes to be optimal for the case of insider patentee. Later, more recently, we followed up the similar study with the outsider patentee. We also introduced when the patent on the licensee are cost asymmetric as well. And then we have a variety of results on optimal contracts. Sometimes royalty to both can be optimal, or fixed fee to the efficient firm can be optimal. So you see, that's also addressing Pradeep's one of the concerns. So you see, we change the framework. You see the optimal licensing contracts do, in the results also do change, depending on the situation you are capturing. So it is very hard to find a uniform, like a generic result, which kind of satisfies in all kinds of situations that we are looking at. So that's basically going into the depth of the study. You will find a lot of interesting things happening, as far as optimal licensings are concerned. Now, having said that, let me now introduce the most recent ones that is now talked about is ad valorem royalty. Now, this is also, Iyer was saying that, this is something we should be, looking at, and this is exactly what we bring in this analysis of spatial competition.
Revenue or profit?
I'm sorry?
It's a percentage of revenue or profit?
Actually, we looked into both. We looked into both, and interesting. That's a good question, but we do not find a significant difference in the results. If we look the revenue sharing as opposed to profit sharing, the generic result do not change much. So that's a good news. Okay, so that to that extent you can generalize. Okay. All right, so let's just now, talk about this particular, the model. It's a very simple kind of a Mickey Mouse model, I would say. We are trying to look the optimal licensing contract, with the insider patentee, the two forms. So it's a duopoly model, very simple, one patentee, one licensee. And we're going to look into the following contracts, okay? So the first one we're going to look at is a regular two-part tariff contract, which is a fixed fee and a per unit royalty. Okay, that's the first one. The second one we're going to look at fixed fee and an ad valorem royalty. So it's also two-part tariff, but it's fixed fee and ad valorem royalty. And finally, we are going to look at a three-part tariff. So probably this is the new thing we are going to introduce, more of a general licensing contract, where you're going to talk about fixed fee, per unit, and ad valorem royalties. That means employing all three instruments, whether that can do better than a two-part tariff. So that was the big question we're trying to ask. So we started off with a very simple framework. I think, Georgios, you have a question?
Yes, I have a question about the third policy.
Uh-huh.
If do we observe three-part tariffs in reality, in real contracts?
Very good question. I'm still searching on the empirical, side. We do not really found a concrete empirical sort of study where they talk about this general three-part tariff contracts. But I mean, theoretically, we can ask this question, but empirically, as you said, how relevant is that? I'm still searching on that.
Yes. By the way, franchise maybe, because franchise you pay a percentage of the revenue, but then sometimes they force you to buy some inputs. I mean, some of the, let's say, if you want to, in a food, you have to buy the special sauce from them and you pay per unit. And I don't know, maybe you also pay upfront. something. So it may be where one has to look on franchisees.
Franchisee models.
Maybe
Yes,
that you can find those.
yes. Actually, that reminds me, since we talked about franchisee models, there are, elementary schools, private elementary schools, they are under some franchisee, and they give franchisee to run those elementary schools. You can buy that franchisee and you can run it as independent. And I have seen, because some of, I'm talking about this franchisee model with the elementary schools, because one of our family members are actually, related to that work. And I found a contract, which is like every time a new enrollment happens, there is a fee that goes to the, franchisor. Okay. So that's a kind of, you can think of kind of royalty part. And then when the end of the year, there is a revenue that comes out for the particular franchisee, the franchisor has a share of that. So that's basically ad valorem part. So, I mean, that really reminds me, if we look into these franchisee models, and in particular, I just, to give an example of the elementary schools, they kind of follow this, fixed fee, per unit royalty, as well as ad valorem as a, as an instrument. And fixed fee is upfront fixed fee. So when you buy the franchise, you have to pay fixed fee. So that's basically, one of the areas I think, thanks for that, because I can now look into more, pointed search, find out at least one of the empirical, stories based on that. Yeah.
Sougata, can I just add one comment? Yeah, another thing is that when we find out the optimal values, we actually see that it boils down to a two-part tariff. And then we can find that there are some empirical evidences we found recently where you charge a royalty, per unit royalty, with and create a joint venture. So you share the profit and you also charge a royalty. So in that sense, it also links to our equilibrium three-part tariff contract.
Yeah, so actually Arijit, has, just, told you one of the results that you are getting at. Actually, even though we started with the three-part tariff, instrument, but in equilibrium, actually it reduces to a two-part tariff contract. I'll come to that. So that is, probably that is aspect that is happening due to the particular framework that you are using. But we can always start with three-part tariff and see, how it, reduces. I think this is also related to your work that with Ma, that, you start with a general, three-part tariff contract and it reduces to a two-part tariff, and equilibrium can be a possibility. So that can happen depending on the framework that you are using. Okay.
One question again, ad valorem on, you have also on profits, right? You said.
As I said, you can have a revenue sharing or profit sharing. Doesn't make any difference.
It's like a fixed fee. Ad valorem royalty on profits. Isn't it
model? In a Cournot model.
Yeah.
In a Cournot
model. That's a
fixed
result we published with the Journal of Rabbi Amir, the editor.
Yes, but that's not the case for hoteling, maybe. Yeah. Let's see.
So
okay.
Let's see. Yeah. Okay. Yeah. I think, we can come into that.
Hoteling, I'm not sure.
Okay. Yeah. Okay. All right. So what is the linear city framework? And I think most of us know it. It's a simple model with like two forms, A and B, at the two endpoints of the linear city. And then, there's a uniform, distribution of, consumers are uniformly distributed over the line, and demand is inelastic. This is important. So everybody, wants one unit of the good, and, the utility function is, standard, that is, as is described there. And from there, we can derive the demand functions. Okay. So basically you find the marginal consumer, and then you find the number of consumers, who's going to farm A, and what is the total demand for farm A. And then you can also find, what is the total demand, which is basically the complementary set. So the whole market is covered. You assume the full market coverage. So if, demand for A is denoted by QA, the demand for B is basically 1 minus QA. Okay. So we just normalize the total demand to 1. So that's the standard, way of writing the demand functions that originates from the Hoteling's linear city model. Okay. So that's, having said that, yeah. Robert, you have something? Yeah.
This is the original Hotelling model, and the three people at Core published a paper where they said you have non-existence with this model, and that's why you needed to go to quadratic transportation costs to restore existence.
Yes. Now, the answer, yes. I mean, that is true, because if you allow the firms to choose the locations, then you have a non-existence problem with linear city.
Yeah.
But here we are not choosing locations. The firms are at the extent. So exactly. So the existence problem is not here. Yeah. Okay. So what is the licensing game? It's pretty, simple and straightforward. So basically, firm A, let's assume firm A has a better technology, is the efficient firm compared to firm B. And let's say the marginal cost looks like something like this. Since firm A is efficient, is lower marginal cost compared to firm B, CA is less than CB, and firm A can license this technology to firm B. Okay.
So you exclude CA to be equal to CB?
It can be less than equal.
Huh?
It can be less than equal. Yes.
Yeah.
Yeah, I think that should capture, in the analysis as well. Yeah. So the timing of the game is again, we all know this kind of games is stage one. Firm one offers a take it or leave it offer to licensing contract to firm B. Firm B, in the stage two accepts or rejects, and then stage three they compete in prices and profits are realized. Consumers, get their preferred good. So that's again, the usual way we solve this model. Okay, so we're going to use obviously backward inductions for subgrid perfect Nash equilibrium. Now, let me just give you the pre-licensing. Suppose there was no licensing, so this will be like the benchmark. So we're going to compare with what happens after licensing. So what happens before licensing is pretty standard again. So we solve the equilibrium prices and demands in the Hoteling's framework. And for simplicity, let us assume that the cost of the efficient firm is 0. So that reduces our notation. And cost of the other firm, inefficient firm, is C. And the cost of the unit transportation cost is T, is also assumed to be 1. So that reduces notations a lot. And then we can write out this price and profit and quantity expressions using that particular value of the cost and the transportation cost. And then we will also talk about welfare. So we bring the consumer surplus as well as the welfare. So this is the whole analysis under, I just give you the results. And the pre-licensing scenario, what is the profits, prices, quantities, as well as what is the consumer surplus and the welfare. Okay, so we'll keep this in mind because we'll come back to this later after the licensing game. Okay, all right. So now let me just start with the main part of analysis. So I'm going to start with, as I said, a two-part tariff, fixed fee and per unit royalty. Okay. Again, I'm not, getting into, all the, detailed, technical analysis. I just give you the results, broadly speaking. So if you solve this game, you'll find the equilibrium prices looks like something like this: 1 plus R. This is solving the game in the second stage or in the last stage. And then you find the equilibrium outputs. Basically, once you transfer, the technology to the other firm, then obviously the cost of production, it gets affected. Of course, it's a net of royalty. But what happens is both the firms kind of become symmetric, and then they produce, half of, their half of the market, each of them, and that's how the prices looks like. And then if you look at the optimal contract, it's not surprising. The royalty should be equal to the cost reduction. So R star will be C, and then you can find F star. Georgios, you have a comment?
May I interrupt again? Sorry. The firm B pays a royalty, right?
Firm B pays a royalty. Yes.
Why do the two firms then have the same price in equilibrium? Because
so when firm B pays a royalty, right? So then
what happens? Does not pay anything. Does not pay a royalty, firm A, right? Why do they have exactly the same prices in equilibrium?
They have different costs. I hear the same.
They have different because the firm B pays the royalty, unlike firm A. So should they have equal prices in equilibrium? Maybe I'm wrong, but I'm just asking.
Yeah. Actually, it turns out in equilibrium, the equilibrium price is exactly the same. Yes. Yeah.
Okay.
Arijit, you have a comment here? You want to make any comment on this front?
No, I think as you mentioned, that it is coming from that structure and the way that we consider the framework. And one thing, maybe it is because of this what is called that V is not playing any role, and we are actually getting the equal price, and I think that is the driving force.
Okay.
Okay, so I think this is when you solve the
and we have this full market coverage and all these things.
Okay.
Yeah.
Thank you.
Okay, so
what is the marginal cost of so if there is R, what will be the marginal cost of a farm that won't it be added by R?
Sorry?
Yes, CA is missing from the marginal cost of both firms now is missing from the formula. Is this what the Paprillas?
Yeah, so basically the marginal cost becomes 0 for both the firms. Once the technology is transferred, the marginal cost becomes 0 for the firms. And I can look into this, I can come to this later,
Well, why?
Yeah, but then it will be R for farm, like the farm who gets the license, it should be 0 plus R, which makes it R. And that, refers to Yorgos's original point that if they have different cost, how come the prices are same? Maybe.
Yeah, so yeah, when you work out the equilibrium, it comes out, the prices are like this, but I can come back to this, okay? All right. Okay.
Let me understand. Why the marginal cost is 0? I don't understand. Say it again, I missed something. What is C? What is C?
C is the marginal cost. C is
of which? You say CA and CB.
Yes.
You assume CA is 0.
CA is 0.
C. Okay.
Yes. Yes.
Okay. Fine. But now, if CA equals 0, who has the technology? A, yes? In that case, so A is 0. If you ever, is it the 0 makes the profit and the ad valorem profit and ad valorem royalty the same?
No, this is per unit royalty that we are talking about. This is per unit royalty that we are looking at only. So basically, that technology is transferred with a per unit royalty contract, and
but then if you transfer the technology with 0 marginal cost, then ad valorem profit royalty will be the same as ad valorem royalty.
Yeah, I'm coming to the ad valorem
royalty. In which case,
royalty.
this is trivial. Okay. No, because I didn't understand how come that you have revenue and profit, ad valorem revenue and ad valorem profit, the same. And you say, okay, because the assumption is C equals 0. I think that if C is positive, it's not going to be the same. But let's move on. Possibly
one of the what you said that probably working here. But this is the equilibrium. If you solve it, it comes out.
Fine.
Can you go to the previous slide just for a second?
Yes. Okay.
So you see here you have PA and PB. Now, if I take CA to be 0 and CB to be R, I don't get them. They cannot be equal, because effectively CA is 0 because farm A has the new technology, and CB because farm B has the new technology plus paying R. So CA takes CA 0 and CB R, and they are not same.
I need to look at this.
This is this is pre-licensing when there is no R. This page is pre-licensing.
Yeah, this is pre-licensing.
Yeah, that's okay, but I can apply this. That's fine, but I can apply the same equilibrium prices with the new cost. So post-licensing, CA will be 0 and CB will be 0 plus R, which is R.
Right.
Correct.
Yeah.
and R is C. That's the,
Yes,
so you get the same.
yes.
So
Okay.
yeah. So I don't know. Does that
Devaprabha, it might be that when you have this royalty licensing, then you are actually taking into account the royalty income when you are deriving the price. Because when under no licensing, you have only your profit and others' profit. But under licensing and under price competition, you are actually taking into account the royalty revenue you get.
That is true.
Yeah, yeah. Okay.
It does it. You can't just substitute. It changes the.
I cannot just
payoff.
substitute.
Yeah, the first principle is exactly the first principle
in the new game.
Absolutely,
Okay,
absolutely.
okay.
The optimization problem is different. It's not the cannot
The
just
game
put
is
the
different. The payoffs
yes.
are different. Yeah.
Yes, absolutely, yes.
Okay, thank you.
Okay, so now let me just move on to the ad valorem royalty, analysis. So basically, it's the same thing with a fixed fee and ad valorem royalty. So instead of the per unit, we have got the ad valorem royalty. So what happens? We looked into the both profit sharing and revenue sharing. So here, I think let's do the revenue sharing first. So what happens is a part of Firms B's revenue is a share of the revenue goes to Firm A. So D is that particular fraction which has to be denoted which has to be found out optimally for Firm A. Now again we solve the price game and then you go back to solve for the optimal D. Now there is a problem when you solve for the optimal D. You see the optimal D, when you solve it, it becomes more than one, okay, with a non-trivial fixed fee. So when you have a positive fixed fee, and then D star happens to be more than one, but then that means that's not a possible solution because D has to be between 0 and 1 because you are sharing the profits. So that means that there's no positive F under this ad valorem royalty framework. So if we have a positive F, then basically this star is not feasible, okay? So basically that means we cannot have a positive F in this ad valorem royalty contract. So what that means? That means that F goes to 0, so there is no fixed fee part, but we can solve a D from the participation constant of Firm B, which is basically no licensing profit. So basically what happens here, as you see in this equation, so rework the problem. So maximize the profit of Firm A subject to the constant that the Firm B gets pre-licensing profits, which is fine with the Firm B. And then you solve D from that equation. And that is your optimal D star. And that is used to share the revenue between the two firms. Does that make sense here?
Yes.
Okay. So we are getting a royal ad valorem, we are getting a ad valorem royalty contract without a fixed fee, and that happens to be optimal one here. So this is again the analysis with the two-part tariff, fixed fee, and ad valorem royalty. Now let me just make some quick comparisons here.
Just a second. Go back for so pi AD of D. Okay. That is this an increasing function of D up to 9/5? Like just look on this if it makes sense or not.
Yes.
So it's increasing up to 9/5.
Yes. Yes, that's right.
So I mean, so in that case, you increase it. Why F cannot be? I mean, you take F and you can increase it until you get the. You say D does not depend on F. No. Whatever D is, that determines the F, correct? So D cannot be more than 1. By the way, if D is 1, then you get F is negative.
F is negative, exactly.
So you have a constraint. You have a constraint that F is non-negative.
Yes.
Which gives you what is the maximum D that you can go with.
So I think that is how it is solved when you basically have to make the Firm B accepting the contract, which is basically the participation constant, which is basically no licensing profit.
Okay, fine.
And that's how you get your D star. Exactly. That's how you get your D star with a fixed fee 0. because you are extracting everything. You are extracting everything that. Yeah. Yes.
So this D star, you verified that it's a fraction.
It's a fraction. Yes, of course. Yes, we verified that. Yeah, we plotted that No, yeah, exactly. We did verify that it stays between 0 and 1. Exactly. That's important. Otherwise, it will not make sense. Yeah, absolutely. Okay. Okay, so quick comparisons. Since we already talked about two different type of contracts, ad valorem and per unit royalty, and as a this if we is best no licensing as long as Form B is ready.
We don't hear you well. Something. It's only me, or
I think the connection.
Everyone, you're broken.
I cannot hear. I cannot hear.
Yes, it's breaking down.
It's breaking up. It's okay. Yes. It's coming back.
Okay.
That it's the connection is unstable, but now I think you can hear me.
No.
Not yet. Okay.
Anyone is using something that disturb? Maybe we should turn off the microphone.
You can video better band.
It is breaking.
Breaking.
Yeah. Cannot listen fully.
Let me see. A moment. Okay. When talking up.
Try again.
Shall I go out and come back again?
You can do whatever. I hope somebody in your house.
Yeah, that might be a good idea. You disconnect and come back.
Okay.
Yes, disconnect and come back. Yeah.
Okay.
We are still viewing Sougata's screen. Is it possible if he has logged off?
It's not allowing him to disconnect even, maybe.
Oh, that's good.
Shall I call? I can call Ahmed to see. I'm calling Ahmed.
That's good. You can call him and say hello. That's all.
No, but he may be able to fix the problem.
How? I think that it is. We have no problem except for him.
Yes.
So something is at home, maybe.
Yes.
Hello.
Sorry,
did you call me?
Okay. No. Yeah. I was checking. We are having. I think the problem is on the side of the speaker, not our problem.
3, you're neutral.
Yeah.
4.
Can you hear me now?
Question number
yes,
4.
But there is. You can hear you, but someone is talking on the. Please, those of you that talk, make sure that you are muted. Okay, Sougata, maybe now.
Okay, all right, thank you. Okay, let's try.
Oh,
okay.
Now it's good.
Okay, great. Okay, so quickly, some comparison here. So ad valorem royalty is better than no licensing as long as the Form B is not very cost efficient. The whole idea is, if the Form B is very efficient, then basically, the two-part tariff ad valorem And basically the two firms are basically close to each other. Okay, so you are in competition. So basically, when the ad valorem royalty is profitable, that meets the condition that the firm B has to be cost inefficient, significantly cost inefficient compared to firm A. Okay, otherwise, there's no point in offering this royalty. And the other result is firm. If we compare between ad valorem and the two-part tariff contract, it is always a two-part tariff contract which is better than the ad valorem royalty, no matter what, for all cost configurations. So what happens is, in a case of two-part tariff per unit contract, the competitive advantage of firm A is maintained because the royalty is exactly equal to the cost reduction. So the competitive advantage of the royalty, per unit royalty is basically maintained. As a result, it is better for firm A to offer a per unit royalty to the firm B. Whereas in case of ad valorem royalty, what happens? Both the costs become exactly the same. So when the cost becomes exactly the same, firm A loses the competitive advantage. And then, that doesn't, although, the ad valorem royalty has a collusive, impact on the profits, but that the collusive impact on the profit is less than the competitive, effect that is happening, due to the equal cost. So the intuition is that when you are looking for per unit royalty, you maintain the competitive advantage, and hence your payoff is still higher. You are getting additional payments from royalty, whereas in the case of ad valorem royalty, you are losing that competitive advantage. You are just sharing the profits. So basically, that drives this result why per unit royalty is always better than ad valorem royalty. All right. So that's basically the little comparison there. And then I can, I'm just skipping the welfare part. I will come to this later. I'm just moving on to the general licensing contract because this is one of the new things that we're going to do it. So what happens in a general licensing contract is basically we're looking at three instruments together, which is per unit royalty, the profit sharing or revenue sharing to start with, as well as the fixed fee. So with the three instruments, you again write the problem, okay, from the first principle. And interestingly, again, what we get here, as we discussed in the case of the ad valorem royalty case, here we find the optimal royalty turns out to be like this. F star again goes to 0. Okay, the per unit royalty R star becomes exactly C, which is optimal per unit royalty under two-part tariff. And this D star is also the same D star that we have seen before in the case of ad valorem royalty.
Did you check that D star is smaller than 1?
D star, yes, but this is the same D star that we have seen before. So D star doesn't change actually. So the D star that you have seen before in case of the ad valorem royalty case, this is exactly the same D star we are getting here as well. Okay, so of course the D star is less than 1. We check that, and so optimal contract, what you see here is actually reduces to two-part tariff because F star always goes to 0. But however, there is a unit royalty, that is C, that is added in this instrument, as well as the D star, which is less than 1 as well. So
from the optimal contract, we see that R is equal to C. So all the cost reduction is taken back. And on top of that, the firm B pays a part of the revenues. But will it accept this contract, firm B? Is it above its reservation profit? Because
no, again, so basically that D star again comes out on the reservation payoff of firm B, which is the no licensing payoff. Okay,
so you get still higher than the reservation profit because it pays everything, including some part of its revenue. So
yes, it does. Yes.
So let me just to make sure.
Yeah.
So I mean, you put the constraint that that firm, if they deviate, they go back to the previous. So I mean, there's no reason for the licensee would not like to deviate. But I think that if the licensee deviates and say no, he end up with the same thing without paying the D, no?
Yes.
So something is wrong.
Yes. So the total pie is bigger now, after you transfer the technology, okay? Once the total pie gets bigger, even if you pay the royalty, amount, which is C, still you can extract, a little bit from, it is like a two-part tariff. You can still extract a fixed fee. In this case, you cannot extract through fixed fee. You can extract through your D star, a part of the profit. So it is, in a way, a two-part tariff.
Why? Let's say that you are the innovator. You charge me that F0 R stars equal C and D star equal to this creature. If I say no to you, I pay less. I make more. Because then my marginal cost is C, exactly like if you give me and charge me C per unit, but I don't pay the D star. So, I mean, it's not an equilibrium. It's good maybe for the licensor to license, to charge me R star, D star, but why should I say yes to them?
Because this star is actually worked out, equating the...
Unless it's negative, then it makes sense. Let me ask you, C, what are the limits on C?
What is the limit on?
C. I mean, C should be in a certain range. That you have any?
Yeah. Actually, you empirically, yes, or put some values. I think C can be between 0 and 3. Okay, C can be between 0 and 3.
So in that case, the first part, C minus 6 times C minus 6 is negative. And you have to check that maybe the entire thing is negative. So this star may be smaller than 1, but also smaller than 0. Okay, so you actually subsidize me. I mean, you give me maybe that makes sense. But instead of I pay you part of the profit, you pay me part of my profit, my profit or revenue.
Yeah, I think what you were saying is making sense. But I would say that when you talk about a two-part tariff contract, okay, let's say with a per unit royalty and fixed fee, there also you got a R star, which is the per unit royalty equal to the cost reduction, and there's an additional fixed fee component F. Okay.
Yeah.
So that additional fixed fee component here is, I think, is replaced because F star is 0. It is replaced by your profit sharing part, which is captured by D star.
But there is a constraint that I can say no, individually rational. Okay.
No, we are very far.
D star is positive for sure. I say no. So that means that D star is negative by itself is interesting to say that he's better off. The licensee is better. The innovator is better off charging a lot of royalty, but giving back. Not that you take from me, you give me some share of my revenue.
One second. Can I ask a clarification? You are claiming this is an equilibrium with D star positive and R star equals C. That's what you're claiming.
He doesn't say that D star is positive. He gives you a formula. And I suspect that it's negative because the restriction is that C cannot be above 3.
C cannot be above 3. That's right. C cannot be above 3. So our understanding was you can still extract a little bit from the profit with a positive D star, but I will really double check, on this as pointed out, a very interesting point.
But otherwise, it's not an equilibrium. It's not an equilibrium.
No. Otherwise, Yair's point is right. If D star is positive, then the guy will not buy the license.
Yeah,
that is
better.
Can I just make a comment? As far as I can remember, we actually checked that D star is positive. I think what is happening here, because of the price competition, when they are having this royalty, it is creating more collusive outcome and increasing the total profit. It's more like Foliola and Sandonis in that games where welfare reducing licensing, where the price competition is actually going towards more collusive direction and making the total profit higher. So as a result, it is still interested to buy the license.
So I think what you were saying is increasing the total industry profit.
Yeah.
How does
Yeah.
that? Okay, so I'm missing something. Suppose the
because when the licensor is charging the price, it is internalizing its pricing effect on the licensee's profit through the royalty income.
Okay, so if
which
the total
do
pie,
not get under Kuno.
If the total pie goes up, how does the payoff of the licensee go up? He's considering a deviation, not to buy the license, right?
Yes, yes.
So when he deviates, it would, I'm sort of agreeing with Yair that it's like a competition where his own price is C and the other guy is 0, right?
Yes.
Okay, now let him.
But because I am now charging, see what is happening when there is no licensing, the licensee's cost is C. When there is licensing, licensee's cost is still C. But now I am getting that amount as a royalty rate.
Who is I? We are looking
licensor. I am the licensor. I am the licensor.
But we are looking, I want you to look at the payoff of the licensee when he
yeah, that's what I'm saying. That's what I'm saying.
Okay.
So licensee's cost is same under no licensing and licensing.
Correct.
But under no licensing, the licensor is charging, optimizing its own profit, and license is optimizing its own profit.
Right.
Under licensing, the licensor is now getting extra royalty revenue, which is basically the R, which was not before the calculation, and that actually allowing the licensor to being more collusive, playing less aggressively. As a result, it is increasing the total profit.
So the action of the licensor changes. Action
absolutely.
To the benefit of the licensee, and that explains the answer to Yair's question.
Yes.
Absolutely.
So Yair, I now understand why your objection did not work. Because the action of the licensor is not invariant in the two cases.
Exactly.
We assumed unconsciously that he behaves the same in both cases, which was
because that happens in Kuno, not in Batran.
I think this is a good point. This happens in Kuno framework.
Good point.
Here what happens exactly? Here what happens is this is true in the Kuno framework. Yes, but it doesn't happen. Yes, in the other framework.
So the action of the licensor is completely different in the two scenarios.
Yeah,
absolutely.
Okay. And I think to make sure whether D star is positive or not.
It is positive. They are telling us, Arijit,
no, it is positive.
Equilibrium is positive.
Yes, it is zero. It is zero only when C equals 3. Then it becomes 0. The D.
Absolutely.
But,
absolutely.
Yeah.
Absolutely.
But let me just so let me understand. So, and what is the profit of the licensee? In this case,
basically licensee gets a no licensing profit. So basically, it's the standard below the participation constant. So basically, his profit is equals to when he has no license. The pre-licensing.
So why can't you, after if you make some profit, why can't you get it from increasing F from 0?
They don't give him any surplus. They take everything. The licensor takes everything.
Yes.
Right.
Extracts everything.
So that's my question. The licensor, I mean, the licensee end up with 0 profit?
With a pre-licensing profit. Pre-licensing profit. Pre-licensing.
The reservation profit.
Reservation profit. Reservation profit.
The reservation profit. Okay.
Yes.
Fine.
Yes.
Okay.
Because you have to give the licensee at least the reservation profit. Otherwise, he will not participate here.
Yeah.
The participation constant will be violated, right? Yeah.
So this is very interesting. This is very interesting because really, I mean, that part that is R star and D star, that as if you don't see in reality, I think that this really works for franchisees.
Absolutely. I completely agree.
Typically, you force them to buy the inputs from you, some inputs, okay, some raw materials, some sources, whatever, and they take also part of your revenue.
Absolutely.
So, I mean, I think that you should go, I mean, look for, to motivate.
He gave the example from India, one of the most populated countries in the world.
That's
the
a
number
good point,
of cases is much more than Europe.
Absolutely, that's
all the schools doing this double part tariff.
Exactly, Pradeep. I was referring to that because
the numbers are much more than all of Europe, I think.
Yes.
Yeah.
Actually,
So
my wife is related in that business.
By the way, I mean, you should emphasize the explanation that you gave me in the paper.
Yes.
It's really
Yeah, actually, perhaps we didn't mention too much because it is coming from that Foliola Sandoni's games and economic behavior. So we thought that perhaps we don't need to expand. But yeah, I think perhaps it will be better to explain that again.
Yeah.
I think we should, Arijit, because this is a new insight that is coming, and it is not familiar, with
and very
people,
nice, because when the Bapriya and the CEO and myself have the paper that she presented, actually, it looks to me that R&D, I mean, with F equals 0, it doesn't make sense. I mean, it's empirically, you don't see it. But thinking it's over, it makes a lot of sense. Okay?
Yeah.
But the example, one second, the example you cited from India, I'm only talking about empirical, forget theory, about all these elementary school franchises, which is a very huge number, huh?
Oh, yeah.
Okay. That they are in what you observe is all three are positive, right? You say
but actually
true. Yeah, actually, all three are positive because you have to pay
upfront
upfront fixed fee. Also. Yes.
Is the Bapriya listen to us? Sen? The Bapriya?
Yes. Yes.
I mean, we have also, I think, optimal contracts with F equals 0, positive R and positive D. Is this correct?
I think if you, in Kurno, if you allow all three, F is never 0.
What is never 0? What is never 0?
F is never 0, but R can be.
No, R can be and D can be. But F is never 0? Are you sure? At least in the first version.
Maybe I think that's for duopoly, like for some special cases, like if you have only 2 or 3 firms, but in general, F is not 0.
They have 2 firms. So let's talk about 2 firms.
In 2 firms, I think it is possible. Yeah, with 2 firms, it's possible.
Guys,
we should connect. We should maybe cite yours, and you should. I don't know. Whatever.
Absolutely, yeah. Because I think those two papers are kind of looking at general licensing contract three-part tariff. So you are in a Kurno framework, and we are in this special price competition framework. Yes.
Yeah. Okay.
So it's like a complementary sort of studies. I think that's really great. Yeah.
Okay. Guys, it's a very exciting discussion here, but we are 13 minutes over time. So I suggest we just skip the break.
Oh, okay.
Give 1 minute or 2 for Sougata to wrap up and move on to the next talk right away.
Okay. Absolutely. So I'm just straight away going to to my last slide. So just a little bit on the welfare part. So what happens is when you compare the welfare and consumer surplus, those aspects. So consumer surplus happens to be the lowest under the case of general licensing contract, as you can expect, because under general licensing contract, the innovator extracts the most, okay? And the industry profit increases, whereas the consumer surplus goes to the minimum. So, however, if you talk about the welfare part is somewhere in between. The welfare under a general licensing contract is same as welfare under ad valorem royalty, but it is actually less than per unit royalty, okay? So one has to be careful when the government wants to look for any kind of policy prescriptions, then probably, the general licensing contract is not good for the society general, because welfare is a bit less than the per unit licensing contract. However, for the industry profit and innovations, probably that's the best. So there is a bit of a trade-off there. And the consumer surplus happens to be the lowest under general licensing contract. So these are some of the main things that has come out so far, and that's the part of the story until this point. So I'm to stop right here. Thank you.